Welcome to solverfy.
Hi, in this question we have a solid disk which is attached to a mass m1. So it is rotated with the angular acceleration alpha and this is rotating with the acceleration a. So now we have to consider the force balancing condition. So where for mass m1 we have the net force is F into m into a. So F net will be equal to m1g minus t, which is equal to m1a minus, so m1a is equal to m1g minus t. So t will be equal to m1 into g minus a. Now for mass 2 we have torque is equal to I into alpha. So torque is nothing but it is force into perpendicular distance. The force is tension and the distance is the radius of the solid disk, which is equal to I is mr square divided by 2 for solid, and alpha is nothing but it is a by r. So a by r. So by solving this we have the tension is equal to m2 into a divided by 2. Now from equation 1, so this is equation 1 and equation 2. So we can equate both the sides. So we have m2 is equal to, so m2 into a will be equal to 2 into m1 into g minus a. So we have m1 or m2 plus 2 m1 into a, which is equal to 2 m1 g. So the linear acceleration will be equal to 2 m1 g divided by m2 plus 2 m1. Then we have the tension T is given by m2 into a divided by 2. So substituting for a, we have m2 into 2 m1 g divided by m2 plus 2 m1 into 2. So 2 to get cancels. We have this is m1 into m2 into g divided by m2 plus 2 m1. So this is the first part. Now for second part, so when we completely unknown the mass m1, so unknowing m1, so it fell down with a length L. So this fell down with L, length L, so which decreases the gravitational potential energy Ug. So this converts into the kinetic energy. So we have V is the velocity and W is the angular velocity of the pulley. So we have V is equal to R into omega, so that the change in the potential energy will get converted to kinetic energy, which is equal to m1 into gl. So this corresponds to mass 1, which falls with a length L. So this is half into I omega square, which is the rotational kinetic energy of the pulley plus the translational kinetic energy of the body. So now this is equal to, so m1 into gl will be equal to half into m2 r square omega, or m2 r square by 2 omega square plus half m1 into v square. So we have m1 gl is equal to, so that is m into r omega square. So here, so this is half m2 into r omega whole square divided by 2 plus m1 by 2. So v is equal to r into omega. So this is also r omega whole square. So by this we have m1 into gl is equal to m2 by 4 plus m1 by 2 into r omega whole square. So substituting for r omega whole square, we have r omega whole square is equal to, so m1 into gl divided by, taking LCM and substituting, we have this is m2 plus 2m1 divided by 4. So it goes to numerator. So then we have r into omega is equal to root of this term, which is, so root of 4 m1 gl divided by m2 plus 2 m1. So we have the angular velocity omega will be equal to 2 by r. So this is 4, root of 4 is 2, root of m1 gl divided by 2 m1 plus m2. So this is about the answer. I hope this answer will be helpful. Thank you.